Hello and welcome to this session. I'm going to show you an innovative technique for correcting incorrect coolant water mixtures in automobile engines or heavy truck engines. As you probably know, most of the engines that we work on are going to use some type of an ethylene glycol base coolant antifreeze. I've got a few examples of these here. These first three here, this gold, silver, and white jug, are all examples of ethylene glycol-based antifreezes. They can come in a variety of colors. So we've got the kind of the old-fashioned green. We've got kind of a light yellow color here. They come in reds and oranges and purples. Really, one point I want to make starting out is that the color is really insignificant when we talk about what the coolant is. So whether or not it's a pink coolant or an orange coolant or a green coolant doesn't tell us whether or not it's an ethylene glycol or a propylene glycol based antifreeze. So most of what we are going to be working with is ethylene glycol. The exception to that is if you do have a pet safe or RV marine antifreeze like this pink one I've got here, this is going to be propylene glycol based. So this is a non-toxic antifreeze. So we are going to concentrate talking about the ethylene glycol base, but propylene glycol does act very similar. Some of the freezing points are slightly different than ethylene glycol, but not real significant. So we're going to concentrate on talking about the ethylene glycol. So what is the difference in the colors then? Well, the difference in the colors is essentially dye. The manufacturers, the antifreeze, use that dye to help us identify which additive package is in that antifreeze. So there are multiple different additive packages. The old-fashioned green has a certain additive package. If you get into, say, the GM deck school, that's going to have a different additive package. And yet the colors are there to identify which additive package is in there. Because certain additive packages are not compatible with others. So bottom line is we need to make sure that whatever we do with our cooling services, that we are not mixing incompatible cooling packages or coolant packages, additive packages. But this technique that I'm going to show you will work on green, yellow, orange, purple. It doesn't matter so long as it is ethylene glycol-based antifreeze. So when might we want to use this? So talk about some scenarios that we might run into in the service industry. Customer may have a small leak and they have a low coolant light that comes on. So they add some coolant or add some water. And eventually that comes into us and we're going to service and repair that vehicle. We don't know necessarily what they've added. We may have a customer that's just been adding straight water, in which case that coolant is going to have too high of a percentage of water, too low of a percentage of ethylene glycol in it. The danger to this is in cold weather, it could freeze. It also doesn't have the boiling protection and some of the corrosion resistance that we would have if that ethylene glycol or coolant water mixture was correct. The mixture that we're generally shooting for is a 50% water, 50% ethylene glycol mixture. So that's one scenario. We might have a customer adding water that ends up diluting that coolant mixture. We could have the opposite scenario where we have a vehicle that is losing coolant and getting low, and the customer sees it's low and they add straight antifreeze. So you go to a parts store, you can buy 50% mix antifreeze, or we can buy 100% antifreeze. Okay? If we're adding 100% antifreeze, and depending on how much that customer adds, we may end up with a mixture that's very high percentage ethylene glycol. While this doesn't give us, in most cases, it's not going to give us a freeze concern. Depending on the application, in the summer, ethylene glycol does not carry as much heat away, does not do as good a job as water is to transfer the heat from the engine block to the radiator and then dissipate it. So in certain applications, we could run into some overheating concerns if we have too strong of a mixture of ethylene glycol. So we've got a couple of scenarios there. Another one might be where a customer did some cooling system service themselves, maybe put a water pump on, radiator, so forth, and when they added the antifreeze coolant mixture back, they did not mix it in the proper proportions, and they ended up again with either too strong or too weak mixture. And we have all the same issues that we talked about before. Now, what are we going to do about that? Well, so the kind of the standard industry practice right now is there's kind of two different avenues to take. One is we get that vehicle in, we see that it's got an antifreeze protection of 5 below, indicating a really weak mixture. We need to get more coolant in there. So we could do just a complete drain and refill. So we take that whole cooling system, we drain all of the coolant out of it, refill it with brand new 50-50 mixed antifreeze, and get that mixture back to where it should be. And that's a viable option. Okay, we're going to get, the bottom line is we need to get that mixture back with the proper antifreeze in it, and we're not going to run into any problems with reliability. The downfall of this is a lot of modern coolants are becoming quite expensive. Not to mention the time in the shop is very valuable too. Not only to the customer that's paying the bill, but to the shop owner. They want the shop owner, the technician, everybody wants this to be as an efficient process as possible. So in the event when we have a cooling system that has, for example, too little antifreeze in it, it's maybe a -5 protection level, we don't want to spend all that time draining the block and refilling it if the antifreeze that is in there is good. We're not talking about antifreeze that is well worn out and needs a service or a flush. This might be good, clean antifreeze. And we really don't want to just dump it in the recycling bin and put all new stuff in if we don't need to. So I'm going to show you this technique works very good. It's a good alternative to that. So the second kind of industry standard right now is the idea of just drain a little bit out, add a little in. So we maybe have a -5 degree protection level. Let's say we've got a 14-quart cooling system capacity. So the technician might say, I think if I drain a quart out, put a quart in, that should work. Okay, so he does it. He drains a quart out, adds a quart of straight antifreeze, which is going to increase the cooling protection level. Runs it for a few minutes, runs the engine to circulate it, mix all the antifreeze with the existing coolant, shuts it off and retests it. And maybe you didn't quite hit it right. Maybe now we're only at -20 degrees, so still not to that -35 where we want to be. So what does the technician do? Drains another quart out, adds a little more in, runs it again. Maybe this time he's at 35 degrees below zero and he says, yep, I'm good. Or maybe he's over. Maybe he's at -45. Or maybe he didn't quite get to -35. Maybe he's at -25. You can see that depending on the kind of the luck of the draw on this a little bit, there's a little judgment involved there, but we could be draining and filling, and every time we drain, we're draining out more good antifreeze. So if we have to do this 2, 3, 4 times, again, we end up with the issue of we're wasting good antifreeze and we're wasting our time in the shop. So this technique will help solve that as well. Okay, so I'm going to go through an example here of how to both test the cooling system and use this method and use the application that I've developed to help make this process easier. So we have some antifreeze here. This is some straight water. So I'm just going to mix a little bit of this, and I'm going to purposely mix it and not in a 50-50 mixture. Okay. And again, this is an ethylene glycol antifreeze. So first thing we need to do is we need to measure the percentage. We need to figure out what is the percentage of antifreeze in here. Now I just kind of mix these together. I didn't measure anything out, so I don't know the exact percentage here, but we're going to figure that out. So we've got two real techniques or real tools that we can use to do this. So the first is the hydrometer. So if I take my hydrometer and fill this up with antifreeze, or unknown antifreeze, then I can take the reading on here, and if I look at my big needle, I'm at approximately 15 degrees below 0 Fahrenheit. That is my coolant protection level. So obviously not enough antifreeze in there, too much water. Okay? So that's one way to do it. Another way, and actually a way that I kind of prefer to do that, is with a refractometer. These are not very expensive. They've come down a lot in price. They'll give you a more precise reading than the hydrometer. Well, the hydrometer is an all-right tool. It works. They're inexpensive, easy to use, but they're not always the most precise. Okay, once we have the app launched here, we can see that it's a pretty simple app. There's not a whole lot to it. You know, really all we need are two different measurements here, or two different values to put in. We're going to put the system capacity in, which, you know, is pretty simple. You know, if we've got, say, a 14 quart capacity, and we can select quarts, liters, or gallons on here, it doesn't matter. Doesn't make a huge difference in our calculation which unit we use, other than our units in the description of what we need to do to rectify the system will tell us will give us the correct units as well. And then we're going to use the measured coolant freeze point here, and we can put a negative value in. So if we put in negative 25, for example, and we can select whether it's Fahrenheit or Celsius, and it will actually tell us, you know, in this case, the example I gave you here, that our coolant is 45.84% antifreeze and has too low of concentration. To obtain a 50% mixture, we need to drain 1.07 quarts of coolant and replace with full strength antifreeze. So it actually does the math in the background, calculates exactly how much antifreeze needs to come out of that system. So you can see this is a very, very fast, very efficient method of calculating how much antifreeze to pull out, what to replace it with, and kind of a one-shot deal, get that cooling system back to the proper mixture. Okay, we're going to take a look at the formula that kind of is the backbone of this method. It's a pretty straightforward formula. We're just looking at really two different variables in here, two different things that we need to know the value of in order to come up with the answer of, well, how much antifreeze do we need to drain out of this system and replace with either water or pure antifreeze to get our proper protection level. So we've got two different formulas here. Just depends on what we're shooting for our mixture. Again, we're nearly always going to be shooting for this 50-50 mixture. We also do have a formula here that we could use if we were looking for any other particular percentage. So if we wanted 60% or 40%, we could use this formula and we could get that value as well. But we're going to really concentrate on this 50-50 mix. So the two things that we need to know really are the total system capacity and the total antifreeze in the system currently. Okay, so the total system capacity, we're going to look at service information. Simply look up for that year, make, model of vehicle. What is the total system capacity? So it's 14 quarts, 16 quarts, whatever it might be. Then the total antifreeze in the system, we need to look that up a little bit differently. So there's a couple of different methods that we could use to find this, and we'll look at both of those. Okay, so this is one way that we could find how much antifreeze is in our system. We would start by measuring our cooling system protection level with our refractometer or hydrometer, and we would take that number we get. So let's say we measure the coolant protection level of a given system, and it tells us that we have a protection of 18 degrees below 0. Okay? And this happens to be a 14 quart cooling system capacity. Well, we could use this chart, which is on the back of a lot of jugs of antifreeze. We could just take a look at this and we could say, okay, well, if we have a 14 quart system here, well, how much do we need to put in there to have 18 degree protection? And the answer, if we look at our chart, if we follow it up, 6 quarts. So we can kind of make, we can make the assumption or the calculation that in our 14 quart system, if our refractometer or hydrometer is telling us we have 18 degree below zero protection level, that there must be 6 quarts of antifreeze in here. So when we look for this TAF value, this the amount of antifreeze in the system, we're looking for the quarts or gallons or liters, the volume of pure antifreeze in the system. So it's not just, well, we got a 14 quart system and it's full, so we have 14 quarts in there. No, we have a 14 quart system, but if we took all the water away and we only looked at the pure antifreeze, how much is in there? So this is one way we could do it. We could just use the chart that's on the back of many of these jugs of antifreeze, and we could figure it out that way. A second way to figure out how much antifreeze is in that system is to use a freezing point graph such as this. Now, this one happens to be in degrees Celsius, and if we use the same example we just did with the chart, we say that we have a coolant protection level of -18 Fahrenheit. Well, if we can do the conversion, it comes out to about -28 degrees Celsius. So we can use that as well. And what we can do is we can just say, okay, well, if we follow the line down to -28 degrees Celsius, we're right about here. And I would say we're probably about 42%. So we would just take 0.42 times 14, and that would give us the total number of quarts of ethylene glycol in this system. Okay, once we have the values for the total capacity of the system that we're going to look up, and the total amount of ethylene glycol in the system, or the total amount of antifreeze in the system, and that we're going to calculate either using a chart or a graph for ethylene glycol, then we can actually just solve the equation and come up with a solution. So we would take the total system capacity divided by 2, subtract off the total antifreeze in the system, and we would divide that by 1 minus the total antifreeze in the system divided by the total system capacity. This basically gives us our current percentage in the system. We do the math on that and we come up with R here. So this R is the amount that must be drained and replaced with straight antifreeze to obtain the desired mixture. So now this formula, this particular formula here, is if we're starting with a mixture of less than 50% antifreeze. And how do we know that we're less than 50%? Well, we can look at it a couple ways. If our protection level is greater than -34, 35 degrees, so if we're at -20, well, we know we've got a weak mixture, so we've got less than 50% antifreeze. The other thing we can look at is the value right here. If this number, this TAF divided by the T capacity, if that value there is less than 0.5, well, then we have less than 50% antifreeze. So if we happen to have a system that is strong though, okay, then we need to use a different formula. Okay, it's a slightly different formula. And for, again, if we're trying for a 50-50 mixture, you can see that everything is the same except for it's just the negative of this percentage on the bottom. And this is going to give us the amount that must be drained and replaced with water, so clean water, to obtain our desired mixture. Okay, so we just need to make sure we're using the correct formula, depending on do we have greater than 50% or less than 50% antifreeze in the system. So it's definitely a workable formula. You know, most people can handle this, but again, is it going to take you a little more time in the shop than using the app? Definitely. But if you're teaching students especially, it's good to kind of have an idea of what's behind it, not blindly just punch numbers in and say, okay, that's what it's telling me to do, but I kind of have an idea of how it's working behind the system. So I'm going to show you how to use the dilution method on the app as well. So one issue we can have is if we have a cooling system that is very high percentage ethylene glycol, because of the way that the freezing point versus mixture percentage curve or graph works with ethylene glycol, if we have a real high percentage ethylene glycol, it makes it more difficult to calculate what the actual percentage is that's in here. So, for example, on this one, if I check this coolant here now, which I've mixed to be a very strong coolant, so there's a little water in here, but it's mostly ethylene glycol. So if I check this, I'm going to see that we are past -60 on the scale. So the freezing point is less than -60. Now, the problem with this is our refractometer or hydrometer is measuring density or refraction. And that, when we have mixtures that are relatively close to 50-50 or weaker than 50-50, meaning more water, it's an accurate way to measure that. Less so when we get really strong mixtures of ethylene glycol, such as we have here. So if we're using either the formula and calculating it out ourselves, or if we're using the app and we put in a mixture that indicates that we have a high percentage ethylene glycol, we need to do something to make sure that we are accurate here. So if we're using the app, it's going to give us a warning at this point that we have too strong of a mixture, and it's going to suggest we use the dilution method. And it'll actually walk you through and give you the instructions on how to do this. But it's very simple. I'm going to show you now. If we're using the formula, we've got to remember this. If we get an answer that we have a very high percentage ethylene glycol, then we need to know to do this. So that's another reason that application, that app works very well. It's a nice time-saving tool. So this is real simple. So all we would do is if we imagine this beaker right here is our cooling system in the vehicle, okay? We know that it's high percentage. We don't know the exact percentage because it's so strong. All we're going to do is we're going to take equal parts the coolant from our cooling system, okay? So in this case, I'm going to use my beaker measurements because I've got them. We don't have to be that fussy. We don't need a beaker in the shop. If you've got a quarter cup or a tablespoon measure, you could put a tablespoon of coolant from the cooling system into a clean container, okay? And so we're going to add, in this case, I'm going to add 50 milliliters coolant, okay? And I'm going to add 50 milliliters of clean water. So if this was in the shop, we didn't have our beakers, okay, I could add a quarter cup of coolant from the cooling system and a quarter cup of clean water. Gently mix them, make sure we're mixed up all the way. One other thing to remember when you're using a refractometer, if you had any residue in there, you should wash it out between uses. But if we're working on the same vehicle, at least take and suck a few, empty it out, suck a little in. You know, make sure that we've got a representative sample of the cooling system as it is right now, or the coolant mixture we have right now, and we don't have residue from before that's skewing our results. So that's a good practice to get into. So when we take this coolant now, we're going to wipe our lens and stuff. Put a drop on there. And now we're going to check the freeze protection. Okay. So now I am reading that we are at negative, we'll call it negative 18 degrees. So now I can recalculate, assuming that I've got negative 18 degrees here, or simply enter it into the application. Negative 18, and if we're in dilution mode on the application, on the app, it will automatically do the calculation for you, because what it's doing is it's saying, it's going to calculate what is the amount or the percentage of antifreeze in this mixture, and since we have equal parts water and coolant, it's going to say, well, I know that I need to double this percentage. It allows us to get an accurate reading of the percentage of this mixture right here, because we are not so strong on the ethylene glycol that it starts to skew our numbers. So it solves our problem of being too strong on the ethylene glycol and skewing our numbers. But since we know the change we have, basically this is going to be half the percentage of ethylene glycol that the original cooling system was, it allows us to then calculate, okay, what do we need to do with our cooling system to get it fixed? Okay? So once we plug these numbers in, we can look at our app and we can see, hey, we need to take out 3 quarts of coolant and we need to add straight water. Okay, if we're in the case of we need to dilute it down. Or if we have, whatever the mixture is, our app will tell us exactly how many quarts to pull out, what to replace it with, either straight water or a full-strength antifreeze. Okay? And we can run the vehicle and we can be confident that our mixture is going to come out right. Okay? We're going to save time. We're going to have to remove the minimal amount of antifreeze possible. Okay? So we're not wasting antifreeze. It's going to be quick. We only have to do this one time, and we're going to save time. Okay? So we will look at an example of a system that has an excessive amount of antifreeze in it, and maybe we check the coolant protection level, and we are really strong on it. So let's just say we've got a 14-quart system here. So we enter our cooling system capacity, and the freeze point, let's say we put it in there and we got 65 below. So real strong cooling system. And another recommendation I would make is, depending on the hydrometer or refractometer you've got, if you are at the far end of the scale. So if it only goes up to -60 on the scale and you're at -60, I would actually put in -65 just to make sure that we're getting an accurate reading on this cooling system. So let's say I got -65, we hit calculate, and you're going to see this message here that says the percentage of antifreeze is greater than 60%. At concentrations of this level or higher, it is more difficult to calculate the exact concentration. So it's explaining to us that we can't really trust this measurement because we've got that much antifreeze in it. At very high concentrations, the freezing protection may be significantly reduced. Select dilution method to obtain a more accurate measurement. So we can simply click use dilution method, and you see that we've got everything kind of goes in a red font here to alert us to the fact that we are in dilution method or dilution mode. So what we want to do at this point is we're going to take equal parts coolant from the cooling system and clean water. We mix it and recheck the freeze protection level. So we're going to use our refractometer or hydrometer. We're going to recheck that value, and now we're going to enter that new value for our mixture of 50% coolant, not in 50% coolant that we've pulled out of the suspected or the cooling system that we were working on, and 50% water. So we're going to take and enter that in. So let's say maybe now we get a measurement of -8 degrees. Okay, and we hit calculate, and so now it actually does the math for you, does all the calculations, and it's telling you that that original coolant in the cooling system is 74.94% antifreeze. So it took into account the fact that you have just mixed that coolant with an equal parts water, and retested it. So anytime you see this red font here, we know that we are in dilution mode. It tells us that we have too high of a concentration. We need to drain 4.66 quarts of coolant and replace with clean water, and that will give us the proper 50-50 antifreeze mixture in this system. Now if we want to turn dilution mode off, we can simply click the dilution mode enable button, and it will go back to our standard screen. You can see we've got no red on the screen anymore. We know that we're in our standard mode, where it's going to calculate, assuming we're taking a direct reading from the cooling system and we're not using that 50% mixture. If you're using this and at any point you want to get into the dilution mode, the easy way to do that is just put in a freeze point below -65, and it will give you the option to re-enable dilution mode.